Hi guys, how are you? This is our part 3 of LLM from complete scratch. In our last video, we see how to import and open the file, txt file, and how to read it and how to implement tokenizer. So if you not see this part, so you definitely go YouTube and code with Hafiz, and here you will find this the part 1 and part 2 of this. So check there the first two parts of large language model from scratch, and let's begin. What is our first part? We are importing our data, so let's import data, txt file. So let's import it. I am going to import this plain underscore text.txt file from my folder, and after that I am executing this. After that my tokenizer code encoding and decoding, and now I am going to do one more step to encode it, and I am going to encode a single word just for you guys to understand how the encoding will work. So let's say I hello, and here when I print this in code, spell here, please make sure the spelling, this is more effect on our code. Encoded word, let's print the encoded word. Execute this. You see I am getting for H64, for E61, and for L68, and for L68, and for for O I am getting 71. So basically this is encoding, and let's decode it again. Decoded word, and this will decode what encoded word. Let's print the decoded as well. Decoded word. Let's see to execute this. You see I am getting on first print encoded of hello, and then the decoding of this word hello. So let's understand what I am doing here to complete understand each and every step for you guys. See guys, what I am doing here, this line calls the encode function. This encode function with the string hello as input. This encode function converts each character in the input string hello into its corresponding integer index using the string underscore to underscore int dictionary. The result is a list of integers which I am getting here, as you see, using representing the encoding form of the word hello, and it's stored in the variable encoded underscore word, as you see. And on the next line, this line prints out the encoded word. Since encoded underscore word is a list of integers, it will display the list of integers representing the encoded from the word of hello. So on the next line, this line calls the decode function with decode underscore word as input. The decode function converts each integer in the input list back into its corresponding characters using the int underscore to underscore string dictionary as you see here above. The result is a string representing the decoded form of the word, and it's stored in the variable you see here. It's stored in the variable decoded underscore word. On the next line, this line prints out the decoded word. Since decoded underscore word this decoded underscore word is a string, it will display the original word hello, which has been decoded from the list of integers. I hope this will make sense. If any doubt in your mind, please comment it. I am here. I will solve you each and every step of this Scratch LLM code. So, if don't forget to subscribe and like, please, please, please. Let's continue. So, guys, our next step is to import some required libraries. I'm going to import what I am going to import the library, the name of library, import torch. Let's first understand why I am importing this. Let's understand this first. Basically, the torch typically refers to PyTorch, a popular open source machine learning library developed by Facebook's AI Research Lab FAIR. PyTorch is widely used for building and training deep learning models, including neural networks for neural language processing tasks like language modeling, translation, sentiment analysis, and more. So, the PyTorch provides a flexible and dynamic deep learning framework that allows researchers and developers to experiment with various neural network architecture easily, and it also offers support for both imperative and symbolic programming styles, making it intuitive and efficient for prototyping and experimentation. Part PyTorch also provides automatic differentiation capabilities through its dynamic computation graph, enabling efficient computation of gradients for training neural networks using techniques like backpropagation. And PyTorch also has a vibrant community and extensive documentation, making it suitable for both the beginners and advanced user in the field of deep learning. That's why I am using PyTorch. And the PyTorch, in our case, PyTorch is often the library of choice for implementing and training large language model. I am going to implement and train my LLM model using PyTorch due to its flexibility, ease of use, and strong support for building complex neural network architectures. Many state-of-the-art LLMs, including models like OpenAI, AI GPT, Generative Pre-trained Transformer series, and Google's T5 text-to-text transformer, and implemented using PyTorch. So this is some touch on Torch. What why I am using Torch here. So let's import this, execute this. You see, our import is successfully done. I am going to comment these line of codes, and I am going to from tense touch I am going to import what I am going to store data from touch dot we have tensor, and I am going to pass the parameter. This will text, and the next parameter d type is touch dot learn, and I am going to close this and this. After that, I am going to print what from data I want to print out the first 130. So let's print this. Let's first understand what I am doing this. Basically, on this line, what I am doing, I am using PyTorch to convert text data into a tensor of integer values. So that's why I am using tensor here. What I am doing here, by using PyTorch to convert text data into a tensor of integer values. On this line, from torch.tensor, I am going to uh, pass parameters in code, and I am calling text. I am calling a function in code passing the text, and the next parameter is dtype equal to task.long. This part calls the encode function. This part called the encode function on the text variable, encoding it into a list of integer, and the toss.tensor, this part converts the list of integers obtained from encode text into a PyTorch tensor. Once again, I am going to understand you. Task.tensor, this part converts the list of integers obtained from encode text, which will get when I pass this function. This task.tensor will convert the list of integers obtained from this function. Result: a tensor is a multi-dimensional array that can be operated on using PyTorch computational capabilities. So what is tensor? A tensor is a multi-dimensional array that can be operated on using PyTorch computational capabilities, and this parameter dtype equal to torch.long. This specifies the data type of the tensor to be long, which is equal to chosen bit 64-bit integers in Python. So long, which is equal to chose 64-bit integers in Python, and this is commonly used for indexing tensors. And the next line, this line is responsible to print the first 130 elements of the data tensor, and I am using slice the tensor from the beginning up to the index 129 Python. As you know, Python uses zero-based indexing, retrieving the first 130 elements. So this code takes the text data, encodes it into a sequence of integer indices using the encode function. This is for this. I hope this will make sense for you. I just execute this. As you see, I am getting 130 elements. This will make pretty much for you. If any doubt in your mind till now, please comment it. Subscribe. Don't forget to subscribe, like, and share with your friends to understand LLM from scratch and build LLM from scratch with us.